Okay, let's get started. One week of classes to go. How's everyone doing? Yeah, the end is in sight. Okay. Let's talk a little bit about the schedule. We have now finished our discussion of looking outward, where we've been focusing on how C for computers or technology in general can interact with the physical world and hopefully do so out here in the physical world with us. In the next section, looking inward, we're going to be switching gears and going back to how people tend to interact with their environment. And as we do, we're going to look at a number of interactive technologies. So again, our C down here, which is going to be designed to try and hijack this loop. So we're going to have technology that is detecting the actions that the human user is conducting, and then adding to or replacing the sensory repercussion of that action. In the case of virtual reality, we're going to basically have the computer replacing the physical environment. We put on the Oculus Rift, you can no longer see the physical environment, and the computer is trying to supply all of the sensory repercussions for your actions. In lecture 26 in augmented reality, we've got a computer which is, as the name implies, augmenting your interaction with the environment. So now we don't have a screen that's replacing your view of the physical world. You're looking at the physical world through Google Glass or whatever comes after it, and we're trying to add something to it. In lectures 27 and 28, we're going to talk about technologies which are basically moving further and further to the left here, that are actually influencing this action and sensory repercussion link earlier and earlier in your nervous system. So 25 and 26 is technology that's sitting on your person somehow over the skin, and 27 and 28 is going to be technology that is surgically implanted under the skin and is really getting into the nervous system's ability to make predictions about the sensory repercussions of actions even before you've carried out those actions, right? You're thinking about conducting an action, and your brain is a prediction machine. It's making predictions about what the sensory repercussion of that action is going to be. Can we actually create, and why would we want to create, technology that can hijack your mental model, replace or otherwise play with the brain's ability to predict sensory repercussion of action? Yeah? So that's where we're going. We're going to work our way sort of with technologies that are influencing your interaction with the world around you, and do so in a more and more intimate manner as we go. Okay, we'll be starting with virtual reality today, but before we do, let's talk about the third and final report. So we'll talk about that now. It's now up on Blackboard, and it's going to be due on Friday. And after that, you have a week to put the finishing touches on your educational system, and you're going to be presenting your system in class here on Friday, December the 16th. There are going to be very, very short oral presentations. I haven't worked out how short yet, but somewhere between 3 to 4 minutes. Very short. We'll talk about that next Friday. Any questions about report number 2? We're all good, right? Okay. Report number 3, pretty short, not a lot to do here. Basically, what you're going to be doing in report number 3 here is reporting on the changes you've made to your system as guided by your user testing. So you're going to be presenting us with version 2.0. As was mentioned a few classes back, some of the things you may have learned about your system from user testing is that it maybe is not as smooth as interaction as you had thought, right? What we're looking for in report 3 is specifics. What aspect of your system fell flat based on what metrics from your user testing, right? So submitting a weekly report number 3 that says, I learned that my system was crap through user testing and I improved it. Here are the improvements. That's not what we're looking for, right? We're looking to see that the two users that I tested on, both of them seem to have a problem with this aspect of the system, and that aspect of the system is supported by state number 3, and I went back and changed the visualization of state number 3, and here's a short video of version 2.0 of state number 3 in action. That's what we're looking for, that you work backwards from what you saw during user testing to where the problems are in your code, and you've made some improvement to try and fix that, and you're demonstrating that improvement to us. Make sense? Okay, so pretty straightforward. You're going to be creating a 3x3 table with 3 columns, which is, the 3 columns are what went wrong. So the user was confused at this point, didn't know what to do. Why were they confused? That's you. You've identified that the visualization you were showing at that point was ambiguous, or it was too slow, or whatever it was, and components to improve. I need to make a change to state number 3 and state number 4 to fix what went wrong. Okay, those are the 3 columns, and then I want you to try and explain that for 3 separate aspects of your code. I'm assuming for most of you there are at least 3 points in your system where you've identified that it needs a little bit of improvement. If there are more than that, that's also fine, but at least 3. You're going to be submitting next Friday 6 30-second video clips, a pair of videos for each of these 3 specific interactions, and the pair is before and after. Right? Here's the ambiguous visualization that confused the users, and here's the improved visualization. We don't need any additional user testing here. It should be clear from showing us version 1 and version 2 of that specific interaction that it's less ambiguous, or you've somehow improved whatever the problem was with that part of your system. Make sense? Okay. You can probably guess what we're going to ask you to do between December 9th and the final exam period. Right? It's going to be another round of user testing to see if that is actually the case. So think a little bit ahead to that. Okay, that's it. Any questions? No? Okay, so let's jump back to lecture now. Let's talk a little bit about virtual reality. So let's carry on with our cartoons here. Like I said, in the looking inward part, we're going to start with a person who is interacting with their environment, and they're acting on the environment and sensing the repercussions of that action. In virtual reality, we're trying to replace the physical world with a virtual world as presented by the computer. Right? There's a lot of video games out there that already do that, but the amount of this interaction that is captured is relatively limited, right? So I start up a game and there's a virtual world in that game, and I see some objects in the virtual world, and I push against the mouse, and I know that by pushing the mouse I move my little cursor in this virtual space, and then I click the mouse, I push on the button, and that clicks the object, and then I move the mouse again, and I see the object that I clicked on move, right? There's a visual repercussion of that action. That's pretty limited, however, in terms of the actions and sensed responses, because the only actions in that specific case are moving the mouse and clicking with my index finger, right? I'm not running around and jumping and moving my head and doing all those other things. I may, but that's usually not being captured. And the only sensory repercussion I'm usually getting back is visual, right? Seeing the virtual environment moving, and there may be a little bit of audio as well, but that's it. So virtual reality is the idea of trying to broaden the kinds of actions that are captured by the system and broadening the kinds of sensory repercussions that are returned. So the moment you put on the Oculus Rift virtual reality headset, what additional actions are now being captured by the VR technology? Head position and rotation. Why does that matter? right? This is the bread and butter of virtual reality. Yes?
So that it can simulate in the 3D virtual world. I can't rank both, but it's similar to your heading.
Exactly. It's similar. It's going to change the visual response based on what would happen if you moved your head while you were looking at a physical three-dimensional environment. So as we go through today's lecture, as always, I want you to think about what is the human in the loop expecting to have happen. If I'm looking at a 3D physical scene like I am now, and I either move my body or move my head, what does my brain expect that I'm going to see at the next time instance? And what does a head-mounted display need to project to support that expectation? Right? Okay, so we're going to look at a number of virtual reality technologies today that capture not just head movement, but as many actions as possible and try and provide the appropriate sensory response. That's the literally million-dollar game that's being played with virtual reality, right? How much action can you capture and how much appropriate sensory response, how much appropriate sensation can you return to the user? Some aspects of this loop are easier to capture than others. So assuming you're wearing a headset, then it's relatively easy to capture head position and orientation, and it's relatively easy to adapt what's projected onto the inside of the screen of the headset to give the sensory response. What's particularly tricky, assuming we want to develop virtual reality systems? What actions and their attendant sensory repercussions are going to be particularly difficult to capture? Absolutely, right? So this hasn't quite been captured yet, but as we're going to see in a moment, there are a number of attempts to try. What else? So I put on my head-mounted display and turn it on, and suddenly I'm immersed in a virtual environment. I see that there's a virtual object in front of me. Actually physically interacting with the object, right? I see that object and I reach out to grasp the object, and my brain is telling me that in the next 100th of a second I'm going to feel pressure on my fingertips, and I don't, right? My expectation is frustrated. We've already seen a few technologies that might be able to help with that particular action sensation feedback loop. The ultra haptics, right? So you remember this phased array that we're sending up ultrasound that actually produced vibration on the surface of the skin. It's not perfect, obviously, but it starts to give a little bit of sensation that you're actually grasping something. Okay. Or we hire a bunch of minions to run around and put objects in the right place when they reach out for it. Okay, so this, again, is the game that's being played in virtual reality, paying very careful attention to all of these action sensation loops, and some of them are a little more subtle than others, and some are much more difficult to support with existing technology than others. Okay, so virtual reality, we're also going to talk a little bit about the killer apps, right? As usual, the main killer app is probably going to be video games, and we'll talk a little bit about that, but I also want us to try and think about other applications for virtual reality and augmented reality. Why are games the first application for virtual reality? There's your answer right now, right there. So 2016 isn't quite over yet, but it's projected that worldwide revenues from video games is almost 100 billion. How big a number is that? Well, by comparison, here are revenues from the top grossing Hollywood movies this year. There's a long list. I cut it off with just the top 20. So the top 3 movies this year have each grossed 1 billion, so the top 3 grossed 3 billion, and as you start to march down this list, you'll see that they're They're making much less than the top 3. So depending on where you sum this up, definitely the top 100 or top 200 movies didn't make anywhere near, in total, didn't make anywhere near 100 billion. So video games are now more profitable than the movie industry. A pretty interesting shift that's occurred relatively recently. Okay, so we're now going to start to look at some virtual reality platforms. And these are particular platforms that do not just have a head-mounted display, but are trying to capture physical action. It's a YouTube video, and it's going to summarize these 5 platforms in turn. I'm going to start the video, which is going to start with Catwalk, and I will pause the video when we finish with Catwalk. While you're watching the little segment on Catwalk, I want you to pay attention to this cartoon. Which actions does this particular platform support, and which ones does it frustrate? Okay.
Today we're checking out VR treadmills that are either currently on the market or under development. These devices add locomotion to the VR experience, designed to increase immersion. Let's check them out.
Catwalk is a new omnidirectional treadmill input device. The main problem Catwalk solves is to move within a small space in reality and achieve limitless and continuous movement in virtual reality. With its built-in and wearable sensors, you can literally walk, run, backwards, jump, crouch, and sit in the virtual world. Different games call for different movements. Catwalk allows you to switch actions anytime you want. You can even sit down to drive or fly when a game requires it. We started the project since 2013, and we have made quite a bit of prototypes. During developing and testing, we noticed that in many games, you want to perform different actions with your arms and legs. It was annoying and disappointing if these movements are constrained. And while in a virtual world, you can't see the real one. If there are devices near your arms and legs, you may hit something or get hurt. The creative Catwalk independent support structure and open construction sets your arms and legs free. First, it is very easy to get in. Without a ring or column surrounding you, you can move freely and securely without constraint or worry about hitting anything. You can swing your arms naturally or put your hands to rest down by your sides, getting closer to a natural walk posture. Catwalk has not just simply removed the column and the ring. Our unique design can limit the horizontal moving range and control the vertical movement function while walking and running. It can automatically provide 35 cm vertical moving range while jumping, crouching, and sitting. Meanwhile, it can help users move back to center to adjust the position offset while walking, which can increase the sense of balance and safety. When we walk in real life, friction is what propels us forward. Frictionless walking is awkward, like walking on ice, if you must pay attention to keep balance. Catwalk uses high-friction material surface and uses a constant force of rolling friction to simulate real walking forces and human motion. This makes you feel like you are walking on real ground instead of sliding walk. With normal friction, it is easier to keep balance, and it will decrease the time it takes anyone to learn to use Catwalk. Catwalk uses a lower cambered base to transfer potential energy to kinetic energy and to reproduce the movement locus. All of this is to achieve a more natural feeling of walking. You can use it to enjoy relaxing virtual reality games or applications in a comfortable way. Just sit back and relax. Our software can transfer body motion to keyboard or gamepad. This means all the games with keyboard or gamepad support will be playable. We are also developing our own SDK and demo to achieve analog movement and independent walking and looking direction. The prototype you see here is kind of big. This was made to prove our brand new solution. We already have all the plans to make it smaller and lighter.
Okay, so Catwalk meets or exceeds sensor motor expectations, right? So we can also add to what you would expect from a particular action. Which particular actions are supported with this system? You can walk around, yes. So most of the ones we're going to see are trying to support that. Again, without having actually worn this device, why does it give a realistic sense of walking, or why not? Obviously, this is a commercial, so they're playing up the pros and kind of hiding the cons, but they're in there if you pay close attention.
They said the way that they worked with the friction, it makes it feel like you're actually walking the surface.
Absolutely, right? So now you got to think very carefully about when you walk, what do you feel and what do you see? So C is pretty straightforward, right? As long as the proprioceptive sensors or the gyroscopes that you're wearing while you're in the device are detecting that you're walking, it's enough to have the virtual display flow past you. But a big part of walking is the proprioceptive response, right? What you actually feel in your legs and most importantly in your feet, right? So when you take a step and you plant your foot, you pull a little bit with that foot and draw your body weight forward, right? As they said in the video, that's why it's very uncomfortable when you walk on ice, because you don't have that opportunity anymore. So they had those high friction rollers on the underside of the feet, so you got to wear special shoes when you're in this device. But those little wheels are also turning. If they didn't turn, you would step outside of the bowl. Okay, so they're trying to support that feel in the system that when you plant your foot and you pull, that your body is moving forward. In this case, it's not. Your body is staying more or less stationary and your foot's coming towards you, right? So it's a little bit of a tricky thing. They're trying to meet this with these high friction wheels. So it's close. What else about walking here is supported or frustrated?
Turning around.
Turning around, why so?
The giant robot arm thing.
That's right. So there's something attached to you, right? So definitely you can feel that something's attached. Most of the devices, if you look carefully throughout these 5, are motion compensating. So they're actually, some of them are robotic and they actually sense your movement and try and move with you so you don't have that additional proprioceptive load.
I guess I don't really understand why, but they were talking about the surface of it was actually concave that you're walking on
Why is that?
instead of flat.
Yes, exactly. Why a bowl? We're going to see I think 2 of the devices here have a bowl and the other are flat surfaces. Why the bowl?
Well, with the little wheels things, as you walk, because it's a bowl, your feet would naturally pull back to the center.
Absolutely, right? So if you had those high friction shoes on and it was flat and you step, it's less likely that your foot is going to be drawn back towards you, right? So you need to make sure that, because again, you can't see where your feet are, that generally speaking, your feet are always being pulled back underneath you and you're staying in more or less the same place. Most of these systems are set up to make sure that you're naturally always being drawn back to center, while your sensory system is telling you that you're not being drawn back to center, right? That's the whole idea. Give the illusion of infinite motion while making sure that you stay in the same place. Kind of tricky. Okay, so let's think about the bowl for a minute. It's a good solution because it gets your feet back under you, but it also frustrates some other aspect that your brain is expecting when you walk.
I mean, I assume you would feel that you're constantly on an incline.
Of course, right? So you're wearing this thing and you see that you're running through a game and the ground is relatively flat, but your feet and your legs are telling you that it's not flat. Why? Again, we're really trying to dig into this sensor motor loop. Why? What is it about the senses of your body that are telling you that you're not walking on flat?
Your ankles are...
Absolutely, right? So when you're walking on flat, your body is actually making a pretty good prediction of exactly when your feet is going to feel contact. You've probably all had the experience of walking up or down stairs and you miss a step and you stumble. You stumble and catch yourself before you fall because your brain has caught the fact that it made a prediction and that prediction has not been fulfilled, right? That is a very, very important prediction to match because your body is wired up to say if that doesn't happen, you're either about to walk off a cliff or fall or something is about to happen, right? So your visual sense is telling you that there's flat ground in front of you, but your feet are telling you that you're walking on an uphill or there's an obstruction. So obviously the actors in this video are not stumbling, but I would bet for a first-time user of this system, it's going to feel quite uncomfortable because it's not unlike the sensation of stumbling over an object you didn't see or tripping on the stairs.
Wouldn't your sensor motor expectations change though? Like I know there's an example of a guy that made a bike that turns the opposite direction.
Absolutely.
While,
Absolutely, right? So all of these systems and all of the augmented reality and the cybernetic technologies we're going to talk about are assuming that the brain will make up the difference. As you start to get used to it, your body will adapt. Okay, what about exceeding expectations? So as I'm walking around in the physical world and I try and sit down, it's not going to work unless I see a chair there. So there are additional interactions that are made possible in the Catwalk because of this harness. So this is what I came up with, at least. They made a big deal in the video of no occlusions, which again is pretty important. So if I see nothing in front of me and I'm swinging my arms and I hit something that I can't see, my brain is telling me that there are invisible obstructions in this virtual environment. That's not very good. So getting rid of occlusions is a big one. Enable sitting, and there's no lag. So a big part of making predictions about sensory repercussion is not just what sensation am I going to receive when I act, but when. Right? So luckily, because most of the walking in this system is mostly mechanical with these high friction rollers and so on, what you would expect from walking is coming back at exactly the right time. It's just not quite what you would expect. The timing is off a little bit in terms of when I feel contact. Yes?
I'm confused how it enables sitting. I understand you can sit, but would you feel the same motion sitting in a harness than when you're expecting to sit in a chair?
Yes, that's right. I don't know if it's exactly.
So I'm on the website right now, and it's hooked into a harness.
You just hooked, exactly. So again.
Or you can buy a chair with it, but you have to set up the chair with it.
And then that doesn't sound, now you're back to occlusions, right? So again, you see a virtual chair, you turn around, you sit in it, it doesn't feel like actually sitting in a chair, it's something else.
It's like you're just hanging in the air.
Well, I don't know if so does it feel like you're hanging in the air? I don't know, I haven't been in this device. The attempt is your brain might say, okay, this isn't quite sitting in a chair. I see the chair, I feel that I'm sitting in it, doesn't feel like sitting in a chair, but close enough. I feel that I'm walking and I'm kind of feeling the sensory repercussion of walking. It's not perfect, but close enough, right? With all virtual reality, unless we do some surgery, it's always going to be that way, right? It's not quite perfect, but is it good enough to trick the brain?
My other question with this, because we're focusing on video games, are these problems more on the hardware end, or should we try solving them on the software end?
In all of them, it's both, right?
So,
exactly, because again, it's not just hardware or software. It's a combination of the two. Assuming you have a head-mounted display, then of course there's the software component, right? Detecting the actions themselves is going to require some pretty sophisticated software and all the machine learning stuff that we've been talking about, right? Is the user walking? Are they in the initial stages of sitting? Are they getting ready to actually jump? What is A, right? That's software. A lot of this might be then supplied by hardware, like a passive harness to capture you, again. Some of the solutions are done in hardware and some are done in software. So again, this is one of the interesting HCI and creative challenges of virtual reality is it's both, right? How to combine hardware and software to support the illusion that you're walking or jumping or what have you.
I guess I need to rephrase the question.
Sure.
How much of it is game design? Because when it comes down to it, you can create these virtual worlds where you walk in, but that's just a walking simulator in terms of gameplay.
Exactly.
Are you limited? Should you limit yourself gameplay-wise to better suit the hardware?
So
or should you make it a game first and then adapt?
So as most VR companies have realized, this is what you should be developing virtual reality for first, right? This is the first mover market. Make sure you develop VR that's adopted by the gaming culture. Once that's established, then you can move on to other niches other than video games.
Like watching The Lion King?
Like what? Yeah, sitting back and watching a movie. This one is always kind of whatever, right? Another big sector of the internet, as we all know, is pornography. So that's number 2. Once you got the 2 big nailed down, assuming there is any market beyond that, we're going to talk about that in a moment. Assuming that you can support this illusion, what other markets might be useful for virtual reality?
Well, I was just going to say, in response to his question,
Yes.
I mean, all it has to do is recognize that you're going forward, and you just say, okay, well, when I'm walking forward, I want you to hit W, or the up arrow. Like, all it has to do is simulate an input device. It doesn't really need, in terms of, like, being compatible with games.
That's right. In terms of the visual response, absolutely, right? So in terms of what to project on the head-mounted display,
it just needs to simulate an input device, and then what you do, like walking forward, it's like just sending a keystroke.
yes, for most things.
But
I'm thinking
he was just asking, like,
Oh.
I keep thinking more complex than just you're in a world walking around, or you're in Grand Theft Auto and you have a plastic gun with you, and that's what you're simulating.
Absolutely.
I'm thinking like
So
the
what
video
else
games
is
where
there?
You're doing karate. How do you get that transfer unless you actually know how to do it?
That's the question. That is the big question, right? So how would you do that? So what about fine motor skills? So learning a martial art, or a big potential market is healthcare, training surgeons, right? Anything that requires fine motor control, right? I reach out and grasp an object, or hit someone, or try and cut something with a scalpel. I'm expecting a sensory repercussion.
There's also like, I was listening to NPR like half a year ago, and there's something about like people with certain like neurological disorders where they would put on like a VR helmet while like their therapist was doing whatever, and it would like totally calm them because they'd be like flying through like like an ice cave or something. So there's like a lot of medical applications as well.
A lot of medical applications and therapeutic applications. So the reading for today's lecture is all about exactly what you were just talking about. So what about therapy, right? So for a lot of patients, face-to-face interaction sitting in their counselor's office is a high-stress environment. What else can we do to help get someone over a phobia or something that is physically or socially or mentally difficult?
I think this is already used in training, like they were showing the SWAT guy, but I'm pretty sure that for special ops they use quite a bit of virtual reality.
Absolutely, and as you can imagine, the military is already a couple steps, no pun intended, ahead, right? But it's still the same question, right? How do you support all the sensory repercussions that are expected? Okay, let's carry on. Let's have a look at the Omni system. You know, there's a lot of money at stake by the quality of the videos that are made.
It's great to see everyone here, and thanks for coming to our office. It's a big week for us. This week we delivered the first Omni.
It's kind of where games have always been trying to take you. They always talk about immersion and trying to actually put you in the game. Well, you can't just do that with only a console and a controller and a TV. It is immersive, but yet you know you're still sitting on a couch. Hopping on something like the Omni, where it puts you in the game when it's like you're suiting up to get into the battle.
I have an extremely bad problem motivating myself to do exercise.
Yeah, I broke a sweat in like that short amount of time. It's because you get the heat turned up in here, I don't know.
Getting to enjoy that physical interaction of running and moving and looking and not feel so detached from the world that you're playing in. It's night and day.
I have told people for years, if I could walk across Skyrim, I'd be more fit. And this is exactly that machine. I was like, oh my God, somebody actually made that thing.
I mean, I'm not much of a shooter. I just want to go explore a world, go running in, you know, a world full of dragons and magicians and whatever.
The biggest thing right off the bat is the lack of sickness.
So far, all of my experiences with seated VR, like I have motion sickness stuff, and I had none of that here.
What I loved about it is you're actually playing with people.
The last demo I tried was single player and you kind of walk through this corridor, whereas this one was a little bit more wild because I had a partner there right next with me.
When the bad guys get close to you, you instinctively, like, you move your body away from them, you react. My head moved, and my whole body went with it, and it was cool.
I could have this in my living room with my Rock Band equipment, and I think that's really exciting.
Okay, pros and cons relative to the Catwalk.
Limited to Oculus Rift.
What's that?
Limited to Oculus Rift.
Ah,
from the
okay.
look of it.
Okay, fair enough.
It looks to be more obstructions.
More obstructions, right? So absolutely, you're physically attached to something, you can feel it. Which has an advantage because if you draw back from surprising stimulus, at least you're caught.
Can't sit down.
Yep, can't sit down. As far as I could tell, maybe.
What would happen if you like fell over in it too?
This is a good question of any VR thing, right?
I mean, the first one you could fall over, and because you're in a harness, you wouldn't like hit the ground.
It seems like they're in a harness.
I'm pretty sure the harness is. This is the first thing you need to make sure of your VR system.
They were.
I think so.
I don't know.
Maybe it wasn't so clear, but you can imagine before this is deployed to a general market, that's going to be the first thing taken care of. Okay, let's focus on the walking. So again, a bowl. How is the walking different from the Catwalk? It's a little tricky to see in the video.
Is this one a flat surface? Or?
It wasn't a flat surface, it was still the bowl.
Was it a moving ground like a? I didn't really catch it.
Yeah, it's not a moving ground, just a concave plastic bowl. You saw they were putting on shoes at the beginning, so there are special shoes for this one. Did anyone notice the actual foot movement in the bowl? So the shoes they're putting on are just moccasins. So in the inverse of the Catwalk here is to reduce friction. So you're walking, and then as your weight shifts, your foot slides along the surface back underneath you. So that is, I would imagine, again, I haven't been in these devices, I would imagine the sensation of walking is less realistic in the Omni than in the Catwalk system. It's that sliding movement. Your foot, most of the time when you're walking properly, the sole of your foot is not sliding along the surface of the ground, right? When you walk on ice, and it does, you switch how you walk.
I was going to say it's probably very similar to like the feeling of walking on ice.
Could be. I don't.
You're constantly kind of feel, you're sliding.
Perhaps, right? But then they feel the fact that you're held and maybe you relax a little bit. Hard to say, right? Your brains haven't experienced this particular combination of action, sensation, repercussions before. Okay. So they mentioned no lag and no motion sickness. So the big cause of motion sickness in most VR systems is, in reality, when you move your head or you saccade your eyes, the visual scene immediately changes in response to the motion of your head. In a lot of virtual reality systems, you move your head, what's displayed on the screen stays the same and then catches up. And even a lag of a few milliseconds can be enough to give people motion sickness. Okay. Catches you if you rock back. So again, it helps, it expands the expectations. You can try some unorthodox movements in this device, and you're not gonna fall over. Okay, it's still a bowl, so the foot is hitting the ground earlier than your brain predicts that it will. There's occlusions and no sitting. Okay, let's move on to the Virtualizer.
The Virtualizer consists of three main parts.
Okay.
the base plate with a low friction surface, the pillars, and the ring construction. There are linear guides in the pillars that allow for smooth and quiet vertical movements. This is necessary for crouching and jumping. And in addition to that, the ring construction allows the user to turn around and rotate 360 degrees. We felt that rotating inside of the second prototype wasn't as smooth as we wanted it to be, so we decided to improve the mechanism of the ring construction. Furthermore, we also refined the sensor system that detects the rotation of the user. We've also changed the linear guide system inside the pillars, which is now smoother, more quiet, and more durable. On top of that, the new system is lighter than the previous one, so we have saved some weight. Another major improvement is the material that we use now on the base plate. For us, it is very important to have natural walking and running inside the device. So the friction coefficient is now on a level which is ideal for natural movements. When we started developing the Virtualizer, we made some experiments with different shapes and also made a motion analysis in the laboratory. And we've also tested the different shapes in action. And we've realized that the flat base delivers the best immersion. Now, if you use a bowl shape, your feet would touch the slope of the bowl earlier than you would expect, creating a discrepancy between what you see and what you feel. And this breaks immersion and pulls you back into reality. Stability is very important for us, so we decided to use 3 pillars instead of 2 or just 1. The reason is that 3 pillars absorb the forces and the momentum caused by the user better than 2 or just 1 pillar.
Okay.
And since you're able to sit down in the Virtualizer, we had to make sure that the construction supports the user's weight.
Speaking of the sitting function, obviously you have to be fixated inside the ring to perform moves like jumping and crouching, and also of course to sit down. Does the user have to carry all the weight of the ring construction as well while he does so, or do you have a solution for that as well?
We have a special construction in the pillars, in the linear guides, which compensates the whole weight of the ring construction, so the user doesn't have to carry the weight and doesn't feel anything of the ring construction.
Okay, so one thing you notice about the new prototype is that you've constructed a black bar, which is hanging above your head now. Could you maybe explain the reason for it being there?
Sure, yes, we call this black bar the arm, and it is constructed because of head-mounted displays and earphones which are wired.
Okay.
So you can guide the cables over your head and don't get disturbed in the virtual world.
Okay.
And it is designed that way that you can still aim upwards without tossing against it.
I see, so it's for completely unrestricted movement.
Absolutely.
Okay, I see. Okay, Dunja, I think that's enough for now. Thank you for taking your time off to show us the Virtualizer.
You're welcome.
Okay. Pros and cons of the Virtualizer.
Foot hits the ground when you expect it to.
Sorry?
Your foot hits the ground when you expect it to.
So no bowl anymore, right? So at least they got that part right, but they sacrificed what by getting rid of the bowl? Friction, right? So you're in there in socks, and you've got to kind of actively pull your foot back underneath you, and the sole of your foot can feel that your foot is sliding across a surface, while at the same time your visual sense is telling you what you're seeing in the game is that you took a step, and it's your body that's moving forward over your foot, right? So if you took off the device, you would see that the world is not flowing towards you when you took a step, right? So you have a little bit of a discrepancy between what the visual sense is telling you and what proprioceptive and tactile and pressure sense in your feet are telling you. I don't know if that gives you motion sickness, but again, it's this bit of a discrepancy. But at least it's supporting this issue about the lag, about when the foot is in contact with the ground. What else is different about this system compared to the other two we've seen so far?
It was kind of clever that they did wire the, I mean, it's the same, I guess, as the first one, but.
Right, put the wires overhead to allow turning and try and get everything, at least in terms of the upper body, away, right? No occlusions in terms of the upper body. You still have the ring there for occlusion, but okay.
It didn't seem like the ring would open up like the virtual Omnitrix did. Like it seemed like it opening up and then going in, so you probably would have to like lower it down and then step into it.
Perhaps. I didn't quite see how they got in and out. Maybe that's a little bit more difficult.
I know he said to the guy, because he asked about it too, that you wouldn't feel if you were like jumping or something to that extent, but I kind of feel like you still
Yeah, right. So they made a big deal about jumping in this one, right? So at least when you jump, you're not carrying the dead weight of the ring. So this system, we're again back to human-robot interaction, right? The ring and the three arms, or the three arms and the three pillars are a robot, and the robot is sensing the actions of the person. The person has crouched, and they've now started to move upwards, and they're moving upwards at an increasing velocity. They're accelerating. The user is about to jump, right? So the robot senses the fact that the user is in the process of jumping and acts to compensate the weight, right? So those three pillars actually move the three arms up and try and follow at exactly the right velocity profile what the user is doing. And that velocity profile that the robot is moving at is meant to try and produce a particular sensation in terms of the ring while the person is jumping. What is S here? The robot is trying to move the ring so that the user feels what when they're jumping?
Unencumbered.
Unencumbered, right? S equals 0. You shouldn't. Again, they probably do feel the ring, but they're trying to move to minimize this as much as possible. Okay. So again, we're back to a flat surface. So foot collision, more or less when expected, allows 360 turning because of the wire, and they're trying to get no extra weight when jumping.
So a lot of VR is trying to get their immersion. All of them keep talking about how immersive it is.
Yes.
I'm confused. Like I can see it's immersive when you're walking in the game.
Yes.
But I saw two scenarios where I don't know how they're going to figure it out. Like
Which
one
is?
was jumping off the. Like there was a little ledge, and he jumped off the ledge and landed, but his body didn't go through that. So I want to know, does the immersion break there? And when he died in the game. I want to how like they can't simulate that, but what happens? Does your immersion just break because you become floating and your body just flies off?
I don't know.
And, yeah.
So it's a good question, right? So it's very difficult to predict before actually doing user testing, like always in HCI. You got to do a lot of user testing to figure out exactly when the immersion breaks, right? So someone's in the game, they said, I was totally in it, but at about 2 minutes and 34 seconds, I lost it, right? I think he said got dragged back to reality, like you guys just did last week, right? What was it exactly that happened? Which aspect of the action sensory repercussion loop was broken to cause that to happen? And does it always happen at the same place for different people? Maybe some people, their brains may be more forgiving of the action feedback loop than the reaching out and shooting or grasping loop, or vice versa, right? What is it about humans and how they differ that might cause some of them to lose this feeling of immersion at different points compared to others? Very hard to predict unless you do user testing, right? If there's a gap in front of me and I want to do a long forward jump, that seems like something that's going to be particularly difficult to support. But maybe not. There may be a particular kind of robotic harness that detects that and gives you the appropriate sensation for that. Okay. Big drawback of this one is, again, sliding while walking. I think we've got enough time to just watch. Actually, let's leave the Infinideck for next time, and we'll pick up here on Monday. You have a quiz due tonight, and do get started on report number 3. Have a good weekend.